Hello there, today we'll be doing threesome. This is much more difficult than twosome, but it is very similar. And I'm not sure if we can do foursome if we know how to do threesome, but we know how to do threesome if we know how to do twosome. Okay, so to do threesome, we're going to use our twosome algorithm. The twosome algorithm is we take the left and right pointer and we look up whether or not these items are equal to the target. We will use our left pointer to be the target and the right pointer to and then we'll create a target at each particular number, and then we'll create a left and right pointer out of that. So here's what I mean. So let's let's sort our items. Alright, and let's set our target to be -4. Then let's set our left and right pointer to be the rest of the items. This way, we already have one item, and we check the two other items. So do this, we can check the left and right pointer. So we see that we're trying to get a total of 4 from the left and right pointer, and we currently have a left and a right. So this adds up to 1, so it's too small, and we keep moving it up. That's also 1, too small, 2, too small, 3 does not equal 4, it's too small, and now they cross. And so that means we move the t up. Then we set t, that we eliminated one option using a -4. We can't get that, so we try -1. Can we get -1 from this? No, that's well, we need a 1, a 1, the opposite of -1, which is 1, and we tried doing that. Can we get a 1? Well, yes, we have a 1. So our first item is -1, 1, and 2. Well, -1, -1, and 2. Sorry. So we have a target, and so we try to see, we make sure that we don't have any duplicates. So we move forward, and no duplicates. And let's try to move 1 down again because it is too big now. So we move 1 down, and we have another option. We have -1, 0, and 1, which is another option down here. Afterwards, these cross, of course, and we move the t. Oh no, this is similar. If we repeat this option, we will have the same item. So target cannot be the same as the previous one. So we keep moving forward. We can also create a set of targets. That way we can record the target. I think that would be a good way to do it, but it uses more memory. So we can just say, oh, if it looks like the previous one, then don't do it. Yeah, or we could use a set. We'll try both a little bit later, and we'll learn a little bit more. So now we tried the last one, 0. Can we possibly get a 0? No, because left and right pointer point to the same spot. Now it's over. Set the target to 1. L and R is the same thing, so it's over. And we set the T to this item here, to the last item. And well, that basically means that T plus 1 is out of bounds, and L minus 1 is also out of bounds. So that's out of bounds, and so we're good. All right, let's solve this problem in this particular method, and let's check it out. So first of all, we set our, we store our nums, and we set our results to empty block. So let's get all our targets. So for t and target, in enumerate nums. So what happens here is we set our target, and we need to make sure that we don't have the same target. And we also need to make sure that we don't skip the first item. Because if we had 0, 0, 0, this was just a thing that we saw earlier. If we skip because it looks similar to the first one, then it would look at the last item. We can't do that. So we need to skip that. All right. Now with that, we eliminate that same target option. Okay, next. So let's set the left and right pointer equals target plus equals 1 and length of nums minus 1. So our total is equal to nums of L and plus nums of R. Oh, one thing I forgot is to set the target. Target is equal to the negative of the target because we want, or we could reverse the nums, but I think we can reverse the target instead. Or we could reverse the total. Either way, I think reversing a total makes more sense. So let's just do that. Fun. Okay, so let's code. Let's lines of code. So if total is less than the target, well, total is greater than the target, that means R minus equals 1. Else if total is less than the target, L plus equals 1. Otherwise, we have something's equal, so append this particular answer, which is the target, and nums of L and nums of R. Great, and we need to move our L plus equals 1 up because we want to keep checking, and we will also want to check whether or not it is the same item, and make sure that we skip that. With that, we are complete with this problem, and we return the results. So, index out of range. Funny. So, I don't know what happened there, but we missed the left is greater than the right. Oh no, we have the wrong answer. So I'm not sure what's wrong. Interesting, indeed. So earlier we did a negative for these nums and we had the wrong answer, while we set the target to be negative and we got the right answer. I'm not so sure what happened there. They should be equal, but there might be some issue with the Python. I'm not entirely sure what that was about, because they should be equivalent, logically speaking. If you know what that is, please comment below and inform me. Right. What we can do to eliminate this line of code here to check that is if we create a set of targets. So targets equals a set of numbers. We'll set an empty set, and after the target is done, we can set targets dot add target, and if target in targets continue. So that way we can make this code a little bit more simpler, hopefully. Let's run the code. Uh-oh, did not work. I thought it should work, but it didn't. Weird. Oh, it doesn't work. I'm not so sure about why that wouldn't work either, because we put it in to our targets and it should continue. That means skipping this entirety of this code. But for some reason, it does not work. And this, on the other hand, works. I think I understand what happened there. It's because we added the negative of the target. How about we set the target earlier, and that way we can get around that. Let's run the code, and we're looking good. Oh, right. Uses more memory, as to be expected. I think it doesn't use that much more, but wow, we solved that. That was nice. I think we can do a little bit more with that logic. We can eliminate this right here. I think we can create a set here and say scene, but I think this makes a little bit more sense. We can create a used num here in this particular item here, and maybe it would be fine. So like used nums equals set, and once the left num is used, we set used nums dot add nums left, and we can eliminate this while left is greater than right, and nums left is in used nums. L plus equals 1. I think we can eliminate this line as well now. Let's run the code. I presume that works. Wow, amazing. I don't know what happened, but we got an amazing time. I maybe because of the set, and it was a faster lookup. I don't know if it's faster at all because we're just incrementing and removing the item. Moving to the next item and looking back, but somehow it's so much faster. Maybe it's a fluke. Let's run the code one more time. I think it's a fluke. If it's the same runtime, then I guess it's not a fluke, and there must be something going on here. And it is still faster than previously speaking, but the memory usage is higher now. But it is faster. Maybe going into an array and finding the memory is a little bit slower than looking it up in a in a set. And because we're using sets now, it's a little faster. And I think sets are a little bit more will get our point across and help us remember how this problem's done a little bit more better in the future. And I think the wording here is pretty good. The usage of target and T is pretty good. I think everything is very good here to remind us that we are. Let's write up what this function does. We get target and iterate and use toSum to get target. Use each number as target and use toSum left and right pointer to get to target, to add up to target, the reciprocal of target, and append and generate a list of zeros. I think that's what we're doing here. In summary, hopefully that that makes sense. This is what this function does. Generate and return list of numbers that add up to 0. Okay, I think that pretty much sums up this particular problem, and next time I see this problem, it will help a lot that I see targets as a set, and what's going on here with will tell us that, oh look, we're creating these targets, we're generating targets with each number, we're using left and right pointers, and we're creating a set so that we make sure that we don't use the same number twice. I think using a set makes a lot more sense, and adding it in, it's much more, I guess, informative than just like L-1. Anyways, the video has gone on long enough. I think we have gone over a lot about pointers and how using the toSum will as a way to get us to 3sum, and maybe, I'm not sure, can we do a 4sum with this? I mean, suppose we add up to 0. I'm not sure how that's done, but that's a problem for another time. I think it's about like stabilizing one target and having another target, and then having 2 items after that, and then moving things along one at a time. So it's pretty. I mean, we can repeat this particular problem. Alright, if you enjoyed this video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.